This is a Chapter 16 review on the different types of probabilities that we've studied. So in the first couple sets of problems here, it says John picks a card from a standard deck. So we're picking one single card, just doing one event. What is the probability of the following events? A black face card. Now, since there are 52 cards in the deck, our denominator is 52. How many black face cards there are? The Jack, Queen, and King of clubs and of spades, so there would be 6. And we simply reduce it, and it would be 3 out of 26. For a face card or an ace, the or being a key word means we're going to add these 52 cards in the deck. How many are face cards? There are 12. There are 4 aces. And there are no cards that are both face cards and aces. So these are called mutually exclusive events. And we would simply just add them up and then reduce. And so going down here, number 2 is an example of mutually exclusive. A spade or a 3, so we're still going to add. A spade is 13 out of 52. A 3 is a 4 out of 52. But there is one card that is both a 3 and a spade. So I do my subtraction, I reduce, and it'd be 4/13. The ace of hearts, there's 52 cards in the deck, there's one ace of hearts, so it's just 1 out of 52. Next set of problems here, same type of thing, picking a card out of a standard deck. A red face card, now we've got 52 cards. There are 6 red face cards, so that'd be 3 out of 26. A black queen, 52 cards. How many black queens are there? There are 2, which would be 1 out of 26. You could still do this by it's a black or a queen. Or no, it is an and problem, so that's the only way you could do that one. Black card or face card. We're going to add these. There are 26 black cards. There are 12 face cards. But there are some black face cards. There are 6 of those. So we subtract 6. Doing that so we don't count them more than once. So I've got 32 out of 52, which would be 8/13. An 8 or an ace, we're going to add these. We have 4 out of 52. 4 aces, 4 out of 52. There are none that are both, so I just add and then I reduce. And since there's no overlapping in the sets, this one is an example of mutually exclusive events. In this next type of problem, we're dealing out 2 cards from a standard deck without replacement. Find the following probabilities. Now, all of these questions deal with face cards, so it'd be very good to just make a tree diagram. And the first card's either going to be a face card or non-face card. The probability of it being a face card is 12 out of 52. Which means a non-face card would be 40 out of 52. Then the second card, if the first one's a face card, could be either a face or a non-face card in both situations. And since we've already pulled one face card out of the deck, in this first situation, there'd be only 11 left out of 51. Which still makes a non-face card 40 out of 51. If the first card's a non-face card, then the second card being a face card would be 12 out of 51, meaning the non-face card would be 39 out of 51. Now we're going to multiply each of these, but I would reduce these to make the multiplication easier. This would be 3/13 means this must be 10/13. 11 out of 51 does not reduce, neither does 40 out of 51. 12 out of 51, if 3 goes into both of these, 4/17, which means this would be 13/17. Then multiplying each of these together, we just multiply top, top, bottom, bottom. So this first one would be 33 out of 13 times 53. Bear with me here a second. Or 13 times 51, which is 663. And each of these reduce. We could take a 3 out of each one. So we have 11 out of 221. The next one, if we multiply, we'd have 120 out of 663, which again we could reduce. We could take a 3 out of each of these. It'd be 40 out of 221. Next one, just multiplying straight across, 10 times 4 and 13 times 17 would be 40 out of 221 also. And the last one would be 130 out of 221. Adding these all up, those should add up to be 221 out of 221. Now answering the question, both cards being a face card, that's a face and a face. We're talking about this situation right here. And so that probability would be 11 out of 221. That the first card is not a face card and the second is a face card. So now we have non-face card, and then the second card is a face card. So that probability is 40 out of 221. Number 10 is a conditional probability. The probability that the second card is a face card, given that the first card is also. So we know we have a face card. The first card is a face card. There's no choice with that. Now I'm picking out a second card. I want to know, is it a face card? That probability would simply be 11 out of 51. Second card being a non-face card is either this one or this one. Since it's or, we can add those together. We just add the tops, keep our denominator the same. Next problem is the same type. We're pulling out 2 marbles again without replacement, which is important. So I'm going to do a tree diagram here. The first one could be red, the second one could be blue. Probably the first one being red is 4/12, which makes the other one 8/12. Second one could be either red or blue. If the first card's red, or first marble's red and not replaced, that means there's only 3 left out of 11, which means this would be 8 out of 11. The first one's blue, second one being red would be 4 out of 11, which would make this one 7 out of 11. These always have to add up to be 1 in each branch. So now once again I could reduce here before I start multiplying. This is 1/3, this would be 2/3. 11's a prime number, don't believe I can break anything else down. So now I would multiply. I'd have 3 out of 33, which is 1/11. So it would be 8 out of 33, which can't be reduced. This would be also 8 out of 33, and both being blue would be 14 out of 33. Once again, adding these across, you'd have 33 out of 33. So the first question, the first marble being blue and the second red. So that is blue, red, which should be 8 out of 33. Both blue, blue, then blue, which should be 14 out of 33. Second one, red, given the first is blue. So the given condition is I'm right here. The first one is blue. It's been not replaced, so now I pick out the next one. What's the chance it's red? It would be 4 out of 11. Second marble being red, that is either this one or this one, which would be 11 out of 33, which is 1/3. Hope this helps. The second part of this video will deal with binomial probabilities and also probabilities using combinations.